It Didn't Start With You, Chapter 2 continued. As a Stanford scholar and researcher from 1987 to 1992, he demonstrated that signals from the environment could operate through the cellular membrane, controlling the behavior and the physiology of the cell, which in turn could activate or silence a gene. His ideas and discoveries, which were once considered controversial, have since been corroborated by many researchers as a result of his work with both animals and human cells. We now know a window of understanding into how cellular memory is transferred in the womb from a mother to her unborn child. According to Lipton, the mother's emotions, such as fear, anger, love, hope, among others, can biochemically alter the genetic expression of her offspring. During pregnancy, nutrition in the mother's blood nourishes the fetus through the wall of the placenta. With the nutrition, she also releases a host of hormones and information signals generated by the emotions she expresses. These chemical signals activate specific receptors proteins in the cells, triggering a cascade of physiological, metabolical, and behavioral changes in the mother's body as well as in the fetus. Chronic or repetitive emotions like anger or fear can imprint her child, essentially preparing or reprogramming how the child will adapt to its environment. Lipton explains, when stress hormones cross the human placenta, they cause fetal blood vessels to be more constricted, sending more blood to the pituitary, preparing the fetus for a fight or flight behavioral response. In this case, a child who experiences a stressful in utero environment can become reactive in a similar stressful situation. There are now numerous studies documenting how a pregnant mother's stress can, as early as the first trimester, affect her child. One such study published in 2010 is Biological Psychiatric, examined the relationship between prenatal stress and its effects on the neurodevelopment of infants. The researchers measured the stress-regulating hormone cortisol in the amniotic fluid of 125 pregnant mothers to determine stress levels. The findings demonstrated that babies exposed to increased cortisol in utero as early as 17 weeks after conception exhibited impaired cognitive development when they were evaluated at 17 months old. In this book, Nurturing the Unborn Child, a 9-month program for soothing, stimulating, and communicating with your baby, psychiatrist Thomas Verney tells us if a pregnant mother experiences acute or chronic stress, her body will manufacture stress hormones, including adrenaline, and travel through the bloodstream to the womb, inducing the same stressful state in the unborn child. Verney goes on to say, our studies show that mothers under extreme and constant stress are more likely to have babies who are premature, lower than average in weight, hyperactive, irritable, and colicky. In extreme instances, these babies may be born with thumbs sucked raw or even with ulcers. Lipton stresses the importance of what he terms conscious parenting. Parenting with the awareness that from preconception all the way through postnatal development, a child's development and health can be profoundly influenced by the parent's thoughts, attitudes, and behaviors. Parents that did not wish to have a child, parents that are continuously concerned about their own and consequently their offspring's chances for survival, women who sustained physical or emotional abuse during their pregnancy, all represent situations where adverse environmental cues surrounding the birth of their child can be passed on to the offspring. With the knowledge that emotions can be biologically communicated and the fact that 3 generations share the same biological environments of the womb, imagine this scenario. A month before your mother is born, your grandmother receives the devastating news that her husband has been killed in an accident. With a new baby to prepare for, a little space to grieve the loss, the grandmother would likely submerge her emotions into the body she now shares with her daughter and grandchild. You and your mother would know something about that grief from a place deep inside you, a place all three of you share. It's within this shared environment that stress can cause changes to your DNA. In the next section, we'll look at how our genes are affected by traumas in our family history. Epigenetics. Bruce Lipton's work on cellular memory both predates and supports the emerging field of epigenetics, the study of the heritable changes in the gene functioning that occurred without a change in the sequence of the DNA. Originally, it was believed that the genetic inheritance was transmitted only through the chromosomal DNA we received from our parents. Now, with greater understanding of the human, scientists have discovered the chromosomal DNA and the DNA responsible for transmitting physical traits such as the color of the hair, eyes, and skin surprisingly make up less than 2% of our total DNA. The other 98% consist of what is called non-coding DNA and ncDNA, and is responsible for many of our emotional, behavioral, and personality traits we inherit. Scientists used to call it junk DNA, thinking it was mostly useless, but they recently began to recognize its significance. Interestingly, the percentage of non-coding DNA increases with the complexity of the organism, with humans having the highest percentage. Non-coding DNA is known to be affected by environmental stressors such as toxins and inadequate nutrition, as well as stressful emotions. The affected DNA transmits information that helps us prepare for life out of the womb by ensuring that we have the particular traits we'll need to adapt to our environment. According to Rachel Yuanda, epigenetics changes biologically prepare us to cope with the traumas that our parents experienced. In preparation for similar stressors, we were born with a specific set of tools to help us survive. On one hand, this is good news. We're born with an intuitive skill set and environmental resilience. As Yuanda calls it, that allows us to adapt to stressful situations. On the other hand, this inherited adaptations can also be detrimental. For example, the child of a parent who early in life lived in a war zone might inherit the impulse to recoil in response to sudden loud noises. Although this instinct would be protective in the event of a bomb threat, such an inherited startled response can keep a person in a highly reactive state even when no danger is present. In such a case, would exist between the child's epigenetic preparedness and the actual environment, such as mismatch could predispose someone to stress disorder or disease later in life. These adaptive changes are caused by chemical signals in the cells, known as epigenetic tags, which attach to the DNA and tell the cell to either activate or silence a specific gene. There's something in the external environment that affects the internal environment, and therefore you know it's a gene. The gene is functioning in a different way. The sequence of the DNA isn't itself doesn't change, but because of these epigenetic tags, its expression does. Research has shown that epigenetic tags can account for differences in how we regulate stress later in life. Scientists used to believe that the effects of the stress were eased in the precursor sperm and egg cells soon after fertilization occurs, before any epigenetic information could affect the next generation, like data being erased from a computer's hard drive. Scientists have now demonstrated, however, that certain epigenetic tags escape